In order to name organic compounds according to the IUPAC system, let's start with the alkanes, and let's introduce one term here because this is how we'll often think about different classes or families of organic compounds. So a homologous series is a term that gets used when we refer to classes of compounds. So the alkanes is an example of a class of compounds, has certain structural features, and we often think of the members of that family one after the other as they get longer. So a homologous series is an IB vocab term that they will sometimes talk to you about, or they'll ask you to pick from, on multiple choice, series of compounds that match the definition of a homologous series. So homologous series is a series of compounds where each successive member differs by one CH2 group. So each member is getting one carbon longer. The first member usually has one carbon atom, but for some families, because of their functional group, the first example has 2 or 3 carbons, and then subsequent members have 3, 4, 5, etc. And when you look at molecules this way, because they're getting longer, they tend to show gradual trends in their physical properties. So things like their water solubility or their boiling point. Because as they get longer, as that carbon chain increases, you're increasing the nonpolar carbon chain of the molecule. You're therefore increasing surface area and increasing London forces. So typically, as we increase London forces, we're going to see boiling points go up, and we're going to see volatility go down. But we're also going to see water solubility go down because the percentage of the molecule that is becoming nonpolar is increasing as we increase that carbon chain. Okay, so that's the term homologous series. These are the first 6 members of the alkane homologous series. Or the first 6 members, simple, straight-chained members of the alkane class of compounds. So to be an alkane means that you are hydrocarbon, so you're C and H only, and all of the bonds are single bonds. That's what distinguishes something as an alkane. All alkanes have the general formula of CN, however many carbons there are, then H2N plus 2. And if you look at the numbers of carbons and hydrogens, the number of hydrogens will always be twice as many as the number of carbons plus 2 more. So that's what the general formula is. So when we name the alkanes, this is going to be a good introduction for naming other molecules. You can see that the number of carbons distinguishes the root or the parent name of the name. So meth is a word, is a root word that we're going to use to mean one carbon atom. And we'll see that pop up in a couple of different ways, but that's what meth stands for. Eth stands for 2, prop for 3, bute for 4, and then the last 2 are pretty easy, pent for 5 and hex for 6. So really it's the first 4 that are tricky, that are hard to remember. So there's a very dumb saying, which is my elephant poops bananas. And that's simply to remember meth, eth, prop, bute. I find people have especially a hard time distinguishing prop and bute, remembering which one comes first. So the silly saying can help you remember the order. So when you see that as part of the name, that tells you how many carbon atoms are in the main chain of the molecule. And then when you see the ending, which in this case is ane for all of these, ane, the suffix, that's called a suffix of a name. So ane tells me that I have an alkane. So when I put that together and I see meth and I see ane, I know that I have a 1 carbon molecule that is an alkane. So that's how that naming system works. If I see butane, I know that I have a 4 carbon molecule that is an alkane. So there's only C's and H's single bonded. Okay? So that's kind of the first thing to address about naming. You're going to see sort of the main root of the name, and it's going to have an ending. And the root tells you the number of carbons in the main chain, and the ending tells you what kind of molecule, what class of compound are we dealing with? Okay. So to begin our naming, we're going to look at just a couple of the different groups. So we just went over alkanes. Alkanes have a general formula of CnH2n plus 2. They don't have a functional group, so this has been left blank. The functional group is the part of the molecule, it could be a single atom or it could be a grouping of atoms bonded together, that give that type of molecule a particular type of chemical behavior, particular types of properties. And you're going to have to learn around 10 different functional groups and what they're called and what types of molecules they are connected with. Okay? So the groups we're going to start with are the halogenoalkanes. Now you can see that that's pretty obvious what we're going to be adding. We've got halogens on alkanes, so they're called halogenoalkanes. So the functional group is simply, I write here as X. It could be F, could be Cl, could be Br, it could be I. Now we can add one of these things or we can add multiple of them. So I'm not going to give a general formula for halogenoalkanes because really there's a number of different combinations that are possible. When we name molecules that have halogens on them, we actually name the halogen, or we refer to the halogen in the front of the name as a prefix. So if you had a chlorine on a methane, you would call it chloromethane. So the chloro part comes first. So these are prefixes. And we'll see examples and we'll practice them. These other two, alcohols and carboxylic acids, so these are all classes of compounds, families of compounds. So to be an alcohol means that you have an OH group. We call an OH group a hydroxyl group. That's the name of the OH itself. And if you have an OH on you as a molecule, then you are an alcohol. And to name an alcohol, you, instead of naming it with the ending ane, which tells you that you have an alkane or a halogenoalkane, we end the name with anol to tell you that you have an alcohol. Okay, now with carboxylic acids, similar idea. This is the functional group COOH, which condensed is written like this, or drawn out with the bonds is written like that. And when we name a carboxylic acid, the ending becomes anoic acid. So a 2-carbon alcohol, we said my elephant, so E is F. So a 2-carbon alcohol is F for 2 carbons, and then anol for the fact that it's an alcohol. A 2-carbon carboxylic acid is F anoic acid. So this part tells you 2 carbons, and this part tells you that it has to have this COOH group as part of it. And then we can work out how that's all drawn out. Okay? Okay, now these here show us one more feature of our organic molecules, one more thing we have to worry about when we name them and draw them. So I see prop and I see ane. So the prop tells me 3 carbons, and ane tells me alkane. That means I only have to worry about using C and H, and I'm going to draw all single bonds. So I remember that's what an alkane is. So these are the clues that I'm getting from the name. So 3 carbons and alkane. Okay, but on the front of this, we have methyl. Well, meth means 1 carbon. So the fact that they've drawn these separate and they haven't just called this thing butane means that I must not have 4 carbons in a row in the main chain of the molecule. The reason why they've separated them is that I have 3 carbons in the main chain, and I must have 1 carbon off to the side as a branch. So when we have branches, we still have to name them. They have to be addressed in the name. They have to be included in the name, but we can't just add the number into the root name, or else it wouldn't be very helpful because we wouldn't know if the carbons are off to the side or part of the main chain. So in the parent name, which is like this propane, I know that I have 3 carbons in the main part of the molecule. And then the methyl that's been added on the front, I know that tells me there's 1 carbon sticking off to the side. Now I have to stick it off the middle carbon because if I were to stick, if I had prop and I stuck a carbon off the first carbon, that just makes the molecule 4 long. That's just butane, and I've just drawn it bent. So you can never have branched carbons, these things that get stuck off on the front of the names, methyls and ethyls. They can never stick off of the end carbons because they just end up making the chain longer. So they always have to go off of the middle carbon. Now the longest chain is 3, and I've got a 1-carbon side chain. And to draw the full structure, I then have to draw in all of my H's. And on an IB exam, you won't receive credit for your structure unless you've drawn in all the hydrogens. But sometimes I leave them out for the sake of time. Okay, dimethyl propane. Once again, 3 carbons, alkane. 1, 2, 3. Now it says dimethyl. That just means 2 1-carbon side chains. And I'm done. Well, I'm done after I draw my H's in. And if you add it up, I have dimethyl, so I have 2 times 1 carbon, and I have prop, which is 3 carbons. Together, I should have 5 carbons. And when I draw it out, I do have 5 carbons. Okay? Okay, as we go down, you'll start to see some numbers. The numbers are used when there's more than one place where I could put these things. And so the numbers tell me on which carbon those things are attached. So on butane, I know but is 1, 2, 3, 4. Ane means alkane. I have dimethyl, so I have these 2 different 1 carbons I'm going to attach. Where are they? One of them is on the 2, and one of them is on the 3. And I can draw them pointed up, and I can draw one up and one down. That doesn't matter. It matters what carbon they're attached to. If I now go through and add all my H's in, I'll have drawn this molecule correctly. The next one, the difference is 1, 2, 3, 4 for but, but 2, 2 dimethyl. That means there's one here, and the other one is also off of that one. 2, 2, they're both off of 2. Notice in the next one it works the same for the halogens. So prop, 3 carbons, 1, 2, 3. It's ane, so it's an alkane. And then I've got 3 chlorines, trichloro. Where are they? On the 1, on the 2, and on the 3. And the rest must be H's. Propan 2-ol. For these functional groups, the numbers refer to the ending. So this fact that it has an ol ending means it's an alcohol. If we go back up here, I know that alcohols means that there's an OH on the molecule. So where is that OH? It must be on the 2nd carbon. That's what that 2 is all about. So prop is 1, 2, 3. It's not propane anymore, it's propanol, and that OH is on number 2. And the rest I can fill in with H's. Okay? And so all naming is just a combination of these rules. It's knowing the endings, knowing when I see ol, it means OH. When I see ane, it means normal carbon and hydrogen, single bonds. And then it just means knowing the numbers. Prop means 3, meth means 1. And depending on where they are in the name, it tells you how they're connected, if they're part of the main chain or if they're part of side chains. So we're going to do a lot of practice on this throughout the unit, but the naming system actually is really logical. There's a lot of names to remember, different endings and such, but the naming system is really logical and step by step, and you're all going to become experts at it.